Hi students, welcome to my channel, Crack Physics with Anisha. Let's make physics concepts simple, fun and clear. In this video, we'll be discussing the remaining part of CBSE Board Paper 2025 set 2 questions. So moving to the next question. An object is placed at a distance of 30 cm in front of a concave mirror of focal length 20 cm. Use mirror formula to determine the position of the image formed in this case. So listen, whenever you are given with a numerical, first of all, you should write down all the data given in it. So here it is given that the object is placed at a distance of 30 cm. That means the object distance is given. Yes. The object distance u is equal to, we can write it as 30 centimeter. Object distance is represented by u. Likewise, it is given that it is a concave mirror. Yes, concave mirror, and its focal length is also given, f. F is given as 20 centimeter. Now, whenever we are applying the mirror formula or magnification formula, something related to mirror or lens, always don't forget to apply the sign convention. So as this is a concave mirror, its focal length is negative because in concave mirror, the principal focus comes in front of the mirror to the left of the pole. So it is negative. And the object distance is also negative because always we take object towards the left of the pole. So all measurements taken towards the left of the pole is always negative and the measurements taken to the right of the pole is positive. Now we are asked to find the position of the image formed in this case. So image position can be found using image distance. Yes, of course, image distance. That is V. So we have to find the value of V. Now mirror formula, according to mirror formula, we know 1 by F is equal to 1 by V plus 1 by U. Simply we have to find V value. So take 1 by V is equal to, what is it? 1 by F minus 1 by U. Yes, correct. Now substitute the given value. So we'll be getting 1 by minus 20 minus 1 by minus 30. Now this can be written as minus 1 by 20 and this minus and minus together forms plus 1 by 30. Yes, now we can cross multiply. So we get minus 30. 1 into 30 is 30 plus 1 into 20 is 20 divided by 20 into 30. And that would be equal to minus 10 by 600. Now we can cancel 1 0 from numerator and denominator. You will be getting minus 1 by 60. So this is the value for 1 by V, that is equal to minus 1 by 60. What we have to find? We have to find the value for V, image distance, that is reciprocal of it, that is minus 60. Don't forget to write its unit, that is centimeter. So the image will be forming at 60 centimeter from the pole of the mirror, and also the image will be formed in front of the mirror. Why? Because it is negative. That means it is a real image. If it is real, definitely it would be inverted. Yes, very good. So we can also find exactly where is the position of the image. As we know the focal length is 20 centimeter, we can say the radius of curvature will be 2 times the focal length, that is 2 into 20. That means it is at 40 centimeter. That means the center of curvature comes at 40 centimeter. So as the object distance is at 30 centimeter, we can say that object is kept between the center of curvature and the focus, right? Therefore, we can say the image is formed is beyond C. If the object is between C and F, the image will be formed beyond C. That's what we have learned, and its value is minus 60 centimeter. Moving to section C, question is define 1 ampere, and second part of the question, the resistance of a wire of 0.01 centimeter radius is 14 omega. If the resistivity of the material of the wire is 44 into 10 raised to minus 8 omega meter, find the length of the wire. Take pi as 22 by 7. Now, first part of the question is very easy to define 1 ampere. Now, what is ampere? Ampere is the unit of current. Now, how we can find 1 ampere? 1 ampere means the current should be equal to 1 A. So, how we can define it? If you know the relation for finding the electric current, I is equal to the relation is Q by T, that means charge by time. So, in order to get current as 1 ampere, we need coulomb, that means the charge 1 coulomb, and time as 1 second. So the current will become 1 ampere. So how we can define 1 ampere? 1 ampere is the 1 coulomb charge. It is basically 1 coulomb charge passing through the conductor per second. Yes, it is 1 coulomb charge passing through the conductor per second. That is 1 ampere. Very simple. The definition is directly given in your textbook. We can find it. So in the next part of the question, it is given as resistance of a wire of 0.01 centimeter, radius is 14 omega. So the radius of the wire is given as 0.01 centimeter. Its resistance is given as 14 omega. And its resistivity is also given. Rho is equal to 44 into 10 raised to minus 8 omega meter. What they have asked to find the length of the wire. So L we have to find, and we can take pi as 22 by 7 for easy calculation. It is given like that. Now, what is the relation connecting resistance, resistivity, length of the wire? What is it? It is R is equal to rho L by A. And we have to find what? Length. So, length is equal to, we can write it as AR by rho. Let it be equation number 1. Now, we have resistance value and rho value, but we don't have area of cross section. Now, area of cross section of a conducting wire is always a circular area. That is pi r square. Isn't it? It gives a circle. So, we can take the area of a circle, pi r square. Now, what is the area of circle? A is equal to, instead of pi, you can write it as 22 by 7 into r square. R means it is given as 0.01. 0.01, that is in centimeter. Convert that into meter. So, it will become 0.01 divided by 100 whole square. That one you can write it as 22 by 7 into 0.0001 whole square. Now, I'm not going to simplify it here. It would be easy if we substituted equation number 1. So, length is equal to area of cross section. I'm writing it as 22 by 7 into 0.0001 whole square. That is the area into the resistance is given as 14 omega. You can give it as 14 whole divided by resistivity, that is 44 into 10 raised to minus 8. Now here, what we are going to do, we are going to cancel the common values. So here 7 and 14, we cancel it for 2 times. Now here 22 and 44, again we can cancel it 2 times. Now this 2 and this 2 can be cancelled out. And finally, we are getting like this. What is it? Yes, this 10 raised to minus 8, power of 10, it is better. Simply don't touch it. You can take that to the numerator. So it becomes 0.0001 whole square into 10 raised to 8. Right? Now, what is the 0.0001 whole square? That is basically 1 by 10,000, isn't it? Yes, whole square into 10 raised to 8. This can be written as 1 square, that is 1 divided by 10 raised to 4 whole square into 10 raised to 8. Now, what is 10 raised to 4 whole square? That is 10 raised to 8. So, numerator is 10 raised to 8, denominator is 10 raised to 8. You will be getting, cancel it out, you will be getting 1 meter as the length of the wire. So, that's how you will be solving this question. So the next question, consider the following electric circuit. A circuit diagram is given. Calculate the values of the following: the total resistance of the circuit, the total current drawn from the source, the potential difference across the parallel combination of 10 omega and 15 omega resistors. So once you are given with a circuit diagram, first of all identify whether it is series or parallel connection. Then it will be easy for you to solve it. So from this figure, we can see that there are 4 resistances. How it is given? 10 ohm and 15 ohm. They are parallel to each other, connected parallel to each other. Likewise, 60 omega and 40 omega is also parallel to each other. But in effect, this 10 ohm and 15 ohm and 60 omega and 40 omega, they are in series, connected like end-to-end connection, right? Yes. So in order to find the effective resistance, first of all, we have to simplify the circuit. So first we'll be simplifying this 10 omega and 15 omega as they are in parallel connection. So I'm taking it as R1. So 1 by R1, effective resistance of 10 omega and 15 omega, I can take it as 1 by 10 plus 1 by 15. But why? The equation is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 for parallel combination, right? So when you cross multiply it, you will be getting 15 plus 10 by 15 into 10. That is 25 by 150. So what is R1? Take the reciprocal. So R1 is equal to 150 by 25. That is equal to 6 omega. Yes. Okay. Now we have to find the effective resistance of the 60 and 40 omega. So we can simplify it further. So 1 by R2, I am taking it as R2. That is 1 by R2, 1 by 60 plus 1 by 40. So that becomes 40 plus 60 by 60 into 40. And that is equal to 100 by 2400. Yes, from that we can find what is R2. R2 is equal to 2400 divided by 100 and that is equal to 24 omega. Correct? Yes. So now if we replace this resistances, four resistances like this, I am just redrawing the figure so that you will understand it easily. Yes. So with two simple resistances, one with yes, one with 6 omega resistance and the other one with 24 omega resistance. That also gives the same effect, same resistance. Therefore, the 6 omega and 24 omega is like in series to each other. So, the total resistance of the circuit can be found as R1 plus R2 and that is equal to how much is it? 6 plus 24 and that is equal to 30 omega. So, this is the total resistance of the given circuit. Now, second part of the question is to find the total current drawn from the source. In order to find the total current drawn from the source, we have to take the total voltage by the total resistance. Now, the total voltage is given in the circuit, that is 15 volt, and total resistance we already found it is 30 omega. Yes. So that is equal to 1 by 2 ampere, or you can write 0.5 ampere. This is the total current drawn from the source. Next, C part of the question, potential difference across the parallel combination of 10 omega and 15 omega resistor. That means this R1. Now, 10 omega and 15 omega are parallel to each other. Therefore, we can say the potential difference, the voltage shared by these two are same, isn't it? Are same. So, we already found the effective resistance of 10 omega and 15 omega. How much is it? That is R1 is equal to 6 omega. We have found it, isn't it? And we know that as R1 and R2, the effective resistances are series. So definitely the current shared will be same. Current shared will be same between R1 and R2. Yes, because in series connection, current will be same but voltage will be different. But in parallel connection, voltage will be same but current will be different. Now they have asked us to find the voltage across 6 omega. So the current across 6 omega will be how much? It will be same as the total current in the circuit, that is equal to 0.5 ampere. Yes. Therefore, the voltage V is equal to, how we can find it? Current into resistance according to Ohm's law. That is, current across the 6 omega is 0.5 ampere into the effective resistance of 10 omega and 15 omega is 6 ohm. That is 6. That is equal to, how much is it? 0.5 into 6, that is 3 volt. So this is the potential difference across this parallel combination of 10 omega and 15 omega. So 10 omega will have 3 volt. 15 omega will also have 3 volt. Yes, that is the answer. Our next question is, draw the ray diagrams to show the nature position and relative size of the image formed by a convex mirror when the object is placed at infinity and between infinity and pole of the mirror. Now here they have asked to draw the ray diagram of convex mirror. Now in the case of convex mirror, we know that there are only two ray diagrams, right? It's one when the object is kept at infinity and the other one when the object is kept between infinity and pole. So let's find out how to draw the ray diagram. So whenever you are drawing a ray diagram, you should use any two rays. Only two rays should be chosen to draw the ray diagram. Now, when the object position is at infinity, if it is a mirror or a lens or if it is concave or convex, it doesn't matter. If the object position is at infinity, that means you should always choose two parallel rays to the principal axis. Now this is a convex mirror, so I can represent the convex mirror like this. Non-reflecting side comes like this, isn't it? Always represent the non-reflecting side. Mark the principal axis, mark the pole, everything as we know. Now this will be the focus and this could be the center of curvature. Now when the object is at infinity, you have to draw the object somewhere far away from the mirror. Now always choose two parallel rays. So the first parallel ray we can draw like this, parallel to principal axis. As it is a convex mirror, it will reflect the ray by diverging it out, isn't it? The light ray will diverges out. Likewise, the second parallel ray, you can draw it from below the principal axis. Yes, like this. After reflection, it will also diverges out. Yes. So in front of the mirror, these reflected rays are not intersecting. They are diverging out from each other. So how will find the image? Definitely you have to extend back the reflected rays, and it is observed that these reflected rays come from a common point behind the mirror, and that is the principal focus of the convex mirror. And that is the position where the image is formed. So image formation can be found by the intersection of the reflected rays. So where is the position of image here? At the principal focus of convex mirror. Now what is the nature of the image formed here? Nature of the image, definitely it is behind the mirror. So definitely I have to write it is virtual in nature. If it is a virtual image, definitely it will be erect. Likewise, how we can find the size? In the figure, it is given that it is like a dot only, isn't it? Yes. So it is a point-sized image. So we can write it as point-sized image or highly diminished, very small. Highly diminished. Diminished means very small. This is how we draw the ray diagram and write down the image position, nature and size. This is for the first case. Now we have to find for the second case also. What is the second case? Yes. When the object position is between infinity and pole of the mirror. Now again we have to draw the convex mirror, mark its non-reflecting side, draw the principal axis, mark its pole, focus and center of curvature. These are very important when you are drawing the ray diagram. Focus and center of curvature. If possible, it is better to mark the angle of incidence and angle of reflection also. So this is the normal. So this represents angle of incidence and this represents angle of reflection. Likewise, that is also better. So now the object is between infinity and pole of the mirror means you can keep the object somewhere near to the convex mirror. So this is the object position. Now except the case of infinity, like the object at infinity, in all other cases, we can choose any two rays to draw the ray diagram. So here I am going to choose the ray which is parallel to the principal axis. After reflection, it will diverges out and it appears to come from focus. That is the ray that I am choosing, the first ray. Second ray, you can choose any ray, no problem. So I am going to choose the ray which is falling at the pole of the mirror like this. Yes. So at an angle of incidence. So it will get reflected back at an angle of reflection which is equal to angle of incidence. Now when you extend back these reflected rays, again you can see that these two reflected rays are intersecting at a point, the meeting point. That gives the position of our image. And you can see that the meeting point is above the principal axis. So definitely the image will be erect. Now we can say the position of image. Where is the image formed? Yes, the image is formed behind the mirror. Yes, behind the mirror of, yes, the convex mirror. Next, nature. Nature of the image formed is, as it is behind the mirror, it would be virtual and the meeting point is above the principal axis. So we can say it is erect. If it is virtual image, it will be erect image. Then size of the image. You can check the height of the object and height of the image. How is it? Image is very small when compared to the object height. So we can say that it is diminished, smaller in size when compared to the object. So this is how you draw the ray diagram and mark its image position, nature and size. The power of a lens X is given as minus 2.5 diopter. Name the lens and determine its focal length in centimeters. For which eye defect of vision will an optician prescribe this type of lens as a corrector lens? That is our next question. So what all data are given? You have to write down those data given in the question. So definitely the power is given as minus 2.5 diopter. Diopter D, it is the unit of power. And name the lens and determine its focal length in centimeters. Now, by observing the sign of power, we can say what type of lens it is. What type of lens it is? Yes, it is a concave lens. From where we got it as a concave lens? We know the equation to find power. Power is basically the reciprocal of focal length in meters. F will be taken in meters, isn't it? Yes. Now, by observing the sign of the focal length of the lens, we can say the sign of the power. If F is negative, power will be negative. If F is positive, power will also be positive. Now, how we can say the focal length of concave lens is negative? Why? Because for a concave lens, it has a virtual focus. So, if this is the concave lens, this is its optic center, principal axis. If the object is on the left of the optic center, the image will be always formed to the left of the optic center only, because here we know that the light rays are being diverged out by the concave lens, isn't it? So it appears to, the refracted light ray appears to come from a point on the principal axis, and that is the principal focus of the concave lens. That is a virtual focus. Okay, as it is a virtual focus and it is towards the left of the optic center, we can say that the focal length of concave lens will be negative. But in the case of convex lens, what will be the type of, sorry, not type, the sign of focal length in the case of convex lens? Except in one case, in all other cases, the image is formed on the other side of the object. If the object is towards the left of the optic center, the image will be formed on the opposite side, right? But in the case of convex lens, the light rays will be converged on a point on the principal axis, and that will be the focus, right? Yes. So this focus of a convex lens, it is a real focus. It would be a real focus, and the focal length is always taken as positive as it is towards the right of the lens, right of the optic center. So focal length of convex lens is always positive and focal length of concave lens is always negative. Remember. So as a focal length is negative, we can say the given lens is a concave lens. We have to determine the focal length in centimeters. Now how we can find the focal length? F is equal to 1 by P. This will give the focal length in meters only, right? Yes. So we can take it first like that. That is 1 by minus 2.5. Then we'll be getting 1 by minus 2.5 is basically 10 by minus 10 by 25. That is equal to minus 2 by 5, and that is equal to minus 0.4 meter. This is in meters. Focal length is in meters we are getting when we directly apply the formula. Convert it into centimeter. How you will do it? Multiply by 100, that is minus 0.4 into 100, that gives Yes, 40 centimeters. This is the focal length in centimeter. Other than this formula, you can choose this formula also. That is F is equal to 100 by P. Why? Directly you will get the focal length in centimeters only, 100 by 2.5. That will be again 40 centimeter. Any equation you can use. That's how we are getting the focal length of the concave lens here. Now, for which eye defect of vision will an optician prescribe this type of lens as a corrective lens? For which eye defect? Definitely it is myopia. Now, what was myopia? Myopia is nearsightedness or short-sightedness where the person can see only nearby object and distant objects are not clear for them. So, the problem they are facing is the image will be formed in front of retina, isn't it? For myopic person, in front of retina, the image will be formed. So, in order to make the the image to fall the image on retina, we have to push back this focus of the lens. We have to increase the focal length of the lens. For that, we can use a concave lens. Concave lens help to increase the focal length and allows the image to fall on the retina. That's how we can correct myopia using a concave lens. Thanks for watching. Subscribe for more videos, hit the bell icon and join our learning journey.